Project Green with part 5 of the Arduino laser array. Now, I have encountered some difficulties. And that was the fact that the ultrasonic distance sensor can only really capture large objects, and it's really not good at determining the environment around it. And why is that? Because how you should know by now that the ultrasonic sound distance sensor works with sound, and so its ability to recognize objects really depends on the ability of those objects to reflect the sound waves back to the echo speaker. And so I was forced to change my testing environment. Now I can catch a large area, and then I can actually use a chair, and it will be able to distinguish where it starts and where it ends. Because I'm not out in the open, it limits what I can do in this project for now while I'm still in the design mode. Once everything is taken care of, once I've factored in all the codes I need for the sketch to do what I want it to do, then I could take it out in the open and we could open up the range of action to the full 0 and 100 degrees. But for now, while we're still testing, this is how I'm going to have to work. Let me show you how the sketch looks as soon as we start recording the measurements in an array. Alright, so this is the same sketch as last time, with a few differences. And those differences are the ones that are going to allow us to store the measurements taken by the sonar into an array. That array is right over here, the dist array. I put in 37 index counts because you can have more. It's better to have more than less. You know, you will waste some memory space, but I'm only prototyping for now. I'm only training, so when the time comes, I will put the index number. I will adapt it to what the situation requires. But for now, while we're training, I'm going to keep it at 37. And so that means that we will going to have an array of 37 spaces that will store each value of the measurements taken by the sonar. And where is it going to take those measurements? On each for loop, just like last time. Remember when it was taking the measurements over here with this command, the sonar ping in centimeters? Well, I'm going to store that value inside the array, and I am going to use this variable. The distance index is the variable of the index that starts off as 0, as you see over here, starts off as 0, and with each loop it will increment over here. I increment it by 1, which means that each time this loop is made, it will store the new value on the new index, and therefore creating our bidimensional map. And here we go down below. As you see, this is the block where I'm going to display those values on the serial monitor. I do that with another for loop, and in that for loop, I use a variable I to increment and display with the serial print, display each value of the distance array one at a time. Each time this loop goes further, it'll increment the I value, and which it will is actually the same value that is going to be shown in the serial print in the index of the distance array. So as you can see, this is the total area being scanned by the sonar. Now let's see how it looks on the serial plotter without any obstacles in front of it. So this is the graph, the serial plotter, without any obstacle in front of the sonar. So we see the blue line is actually the course of the servo motor. That is the angles it is riding from 155 over here where I have the mouse all the way down to 45 and then back up again. And you can see that through those degrees, the sonar has this almost clean reading, right? But it stays the same. And this, where it reaches zero over here, is when, like I told you before, the echo doesn't quite bounce back to the speaker, so it is out of range and cannot read it. But on the otherwise, we can see the wall directly in front at 1 meter 50, and a little bit when the wall starts to stop reflecting the sound back to the sonar due to its angle. The sonar will read a lot more distance than it actually is. But like I said, we have to have an account that this is a sound sensor and it does have its limitations. So let's see how it looks with an object in front of it. And this is the environment of the object, the chair, in front of the sonar. Now let's see how that looks on the graph. Okay, so this is how the graph looks with the chair, with the obstacle in front of it. And as you can see over here, let me just stop it over here. And as you can see, where is it? Here we go. So this is the part where it is out of range, but through the angle of 100 and 50, 75, 175 more, 175 over here, 75. Between the angles of 75 and 100, more or less, we have the reading of 75 centimeters on the orange line over here. And this is where our chair is, between the angle of 75 and 100. So for today, this episode is complete. I managed to build a bidimensional map using the array function. For the next episode, I'm going to have to find a way to compare new readings with the old map. You'll see what I mean in the next episode. So, see you there.